Ammonia gas decomposes according to the equation. So the equation is given below. If 17.5 liter of nitrogen is formed at STP, how many liters of hydrogen will be produced, also measured at STP? So let's go through this question step by step. So step 1 would be to solve for the moles of nitrogen gas. So how do we solve this? We use the ideal gas equation. So the ideal gas equation is PV equals nRT. So if you want to solve for moles, moles is N, you need to divide both sides by RT. So RT would cancel on the right side, and your equation becomes N is equal to PV over RT. Next is we solve for N. P is pressure. So the problem says nitrogen is formed at STP. STP means standard temperature and pressure. And the standard pressure, always remember this, is 1 atm. The volume is given 17.5 liters. R is gas constant 0.0821 liter atmosphere per mole Kelvin. And T is temperature. So the standard temperature, always remember this, it's 273.15 Kelvin. So if you solve for N, or the moles of nitrogen gas, it is equal to 0.780 moles. Then we move on to step number 2. Step number 2 is to solve for the moles of hydrogen gas, H2. So we have solved in step 1 the moles of nitrogen, 0.780 moles of nitrogen gas. When we read the problem, we are given a balanced chemical reaction. And according to the reaction, for every 1 mole of nitrogen, you produce 3 moles of hydrogen. So the ratio between nitrogen to hydrogen is 1 mole is to 3 moles. So we plug that into our equation. So again, the ratio is for every 1 mole of nitrogen, 3 moles of hydrogen. So the moles of nitrogen will cancel. We have moles of hydrogen. And this is equal to 2.34 moles. So the moles of hydrogen is 2.34 moles. Now the question is asking for the following. How many liters of hydrogen will be produced? So it's asking for the volume and also measured at STP. So the final step to solve this question, step 3, is to solve for volume of H2. We will also use the ideal gas equation. PV is equal to nRT. If you want to solve for volume, that's V, you need to divide both sides by P. So volume is equal to nRT over P. N is the moles. So we just solved earlier the moles of hydrogen gas. That's 2.34. So 2.34 moles. R is the gas constant, 0.0821 liter atmosphere per mole Kelvin. T is the standard temperature because the problem says it is at STP. Again, standard temperature is 273.15 Kelvin. Divided by P or pressure, standard pressure is 180 M. So if you look at how the units would cancel, moles would cancel, Kelvin would cancel, ATM would cancel, our unit would be liters, which is the unit for volume. So if you solve for the volume of hydrogen gas, this is equal to 52.5 liters. And this is the answer to the question.